In this lesson, we are going to learn how to use a stoichiometry flowchart. And that is, if we look at the flowchart, we have two different sizes. We have size A and then we have size B. Why are there size A and size B? That is, in some cases, we deal with different chemicals and we can convert from one chemical to another chemical using this conversion factors right here. So going back to the flowchart, we always start from our given and we always end at the unknown unit. And what do I mean by the unit? That is, every little box that you see up here, each one of those represents a specific unit. So you always start from the boxes. Don't get confused and point to the arrow. The arrows are the conversion factor that you have to multiply to get to your unknown. So we look at this format right here. We are looking for the unknown, which is the unknown unit, one of the boxes. And we are always start from our given unit at one of the boxes. And the beauty behind this is that we always start on size A. Okay? And then if we have different chemicals, then we go into size B. That means if we have a different chemical in the problem, automatically you have to assume that somewhere in the problem you are using this conversion factor right there. Number of moles A equal to number of moles B. And that will relate from one chemical to another chemical. So again, these right here are the arrows that you have to multiply by. They are your conversion factors. So let's try one problem together. In this problem, we have a chemical equation below here. Describe a chemical reaction between iron and oxygen gas that produces energy in a new substance called iron oxide, or Fe2O3. So this is the chemical equation that describes a chemical reaction. Now the beauty behind this is that this is already balanced for a chemical, because once our chemical equation is balanced, we can start using the coefficient to generate a mole ratio so that we can relate mole A to mole B. Or in this case, let's look at this problem together. How many moles of oxygen gas are needed to react with an excess amount of iron to produce 3.1 moles of Fe2O3? So we know this is our given. And we are looking for moles of oxygen gas. That would be our unknown. So how will we solve this? Let's go back to the setup of this problem. Now I have this generic setup of this problem right here. If you notice the problem, we are bombarded with a lot of information, but in any stoichiometry problem, we are only focused on the given and the unknown. Because once you have the given and the unknown, you can apply to the stoichiometry flowchart and work it out. So in this case, I'm going to set up in this format. So we have our unknown, which is moles of oxygen gas, and our given unit. Notice how I say given unit, but really truly is our given. In this case, it's 3.1 moles of iron oxide. Then we go back to our stoichiometry flowchart to find what conversion factor we have to multiply to get moles of Fe2O3 to moles of oxygen gas. And we notice the chemical are different. That means we are going from size A to size B in the problem. So if I go back and look at my stoichiometry flowchart, I look for the unit moles on side A, and we know right away this is the unit mole side A right there. So this is where we start, okay? And where are we going to end? We are going to end at the unknown, which is moles of O2. So again, the chemical has changed. And if we look at this flowchart, the only place that has the word mole on it is on size B. That tells you we have changed chemical, which makes sense because here you have chemical A, now we have chemical B. So this is the conversion factor that we are going to multiply by. So this is where we end. So how does that work? The way that works is that you just write down the conversion factor. So we multiply by that conversion factor. All I have to do first is just to copy down that conversion factor number of mole A equal to the number of mole B. And from there, I know that I'm done with this problem almost. The rest is just to substitute in the conversion factor, because I know from mole A to mole B, it's just one conversion factor. So what is A in this case? Of course, A is always our given unit. So what is A? A is one chemical and B is another chemical. And A is always our given unit because we always start inside A. So in this case, A is Fe2O3. And B, of course, is going to be the unknown unit, which is O2. What about the number of moles? We learned in the previous unit that we can use the chemical equation to determine the mole ratio. This is called a mole ratio. So in this case, we go back to our chemical equation and look at the moles ratio between our substances. Based on our problem, our moles ratio would focus on Fe2O3 and O2, and we look for Fe2O3. See that number 2 right there? That coefficient is now part of this mole ratio. So to get the mole ratio, we use the coefficient on the balanced chemical equation to get a mole ratio. And specifically, we focus on Fe2O3. So here we have 2, that'll give you 2. Then O2, we will have 3. See right there? We look for specific substance. That O2 is not the same thing as the O3 here. So don't just look for oxygen, you have to look for specific chemical formula. So this is gonna be 3. And we are almost done. The rest is just to rewrite this as a fraction so we can multiply and cancel out the unit. So we have 3.1 moles of Fe2O3. But how do we rewrite this as a fraction? And the answer is that we look at the previous unit. This is moles of Fe2O3. So this has to be moles of Fe2O3. And right here you can see that this is moles of Fe2O3. So that is going to be on the bottom because we need to cancel it out. So we have 2 moles of Fe2O3. And the top part will be the other side, which is 3 moles of O2. And notice how moles of Fe2O3 cancel out. Let's try another problem based on a chemical equation. In this case, how many grams of ions, which is Fe, are needed to react with 5 moles of oxygen gas to produce Fe2O3 or iron oxides? So based on this problem, our given is right here, moles of oxygen gas. So that is our given. And we are looking for grams of iron oxide. And this is our unknown. So all we have to do is setting up a problem based on this format. Now again, the number conversion factor that we multiply by is based on our given and the unknown and the stoichiometry flowchart. So again, our unknown is grams of Fe. And our given, not just a given unit, our given is 5.0 moles of oxygen gas. And we are going to multiply by a specific number of conversion factor based on the flowchart, based on the ideas that we always start from a given and we end at a known unit. So let's go back to the stoichiometry flowchart. So let's apply our given and the unknown to the stoichiometry flowchart. We start from the given, which is always on size A. In this case, we have moles of O2, and this is the only place that has mole. So this is where we start. Then we look at the unknown, which is grams of Fe. Notice how the substance are no longer the same, the chemical is different. So that tells you we are now on size B. Okay, we are still on size A, we will still CO2. So we're looking for chemical B with the unit of gram, and this is the only place that has mass of B in grams. So this is where we end. To get from moles A, to start from this box to that box, we have to multiply by this conversion factor and that conversion factor. So we go in this direction. This is first conversion factor and that is the second conversion factor. The order of the conversion factor that you multiply must be the same as the one in the flowchart. So this one first and that one second. So let's copy down the conversion factor. Our first conversion factor is number of mole A equal to number of mole B. Then our second conversion factor is 1 moles of B equal to the number of grams of B. Isn't that easy? And the rest is substitute in the conversion factor. First of all, we know A is our given, so A is O2, which is our given unit, O2. And B is a chemical of our unknown, which is Fe. And we go back to our stoichiometry flowchart. The mole ratio is getting from the coefficient number or the subscript. Since we are working with a chemical equation, we get it from the coefficient. So let's go back and look at our reaction. Notice how O2 is right there. It has a specific coefficient of 3, so that tells you there are 3 moles of O2. For Fe, the coefficient is 4, so therefore we have 4 moles of Fe. And that's it for that conversion factor. Now what about the B in this case? Of course the B is going to be Fe again. The variable B doesn't change to C, so still Fe. So we have Fe. How do we determine the number of grams from Fe? This is from the unit where we talk about calculating the molar mass of a substance. So to determine the molar mass of Fe, we have to use the periodic table. So let's look at our periodic table. So this is our periodic table. This is where we get the molar mass. But since our chemical formula is just Fe, we don't have to worry about anything else besides Fe. So Fe is 55.85 grams. And that is the number that go right there. So 55.85 grams. And we are almost done with this. The rest is to multiply this in a fraction form, so that way we can cancel out the unit and the chemical. So let's rewrite this. We have 5 moles of O2 times this conversion factor, and to set this up as a fraction, we look at the previous unit, and this down here has to be the same as that one, so we can cancel out. So this is mole O2, so therefore the bottom part must be mole O2 as well. So 3 moles of O2 go on the bottom, and the other part of the conversion factor has to be on top, which is 4 moles of Fe. Notice how moles of O2 cancel out with moles of O2. And then we move on to the next conversion factor. So we are done with this one, we move on to the next one. Now, so for this conversion factor, we look at moles of Fe, which is now the previous unit of this one. We say moles of Fe is right there, so down here has to be moles of Fe, which is right here. So we have 1 moles of Fe, and the other part will be on top, which is 55.85 grams of Fe. And notice how moles of Fe cancel out. And giving us grams of Fe, which is the same thing as our unknown. And then all we have to do is multiply everything on top divide everything on the bottom. So I'm going to rewrite this out for you. 5.0 times 4 times 55.85 grams of Fe divided by everything on the bottom, which is 3 times 1. But we can ignore the 1. And this is our answer. And we can use our calculator to plug it in and solve for a single number.